What is modulation in two-way radios? Imagine trying to send a message across a busy room filled with noise. How do you make sure your voice gets through clearly? That's where modulation comes into play in two-way radio systems. It's the process that allows radios to transmit voice, data, or other information over radio waves. Without it, a radio signal would just be a steady tone with no way to carry your message. Modulation changes the basic radio signal, called a carrier wave, so it can carry useful information. Think of it like adding a message onto a blank canvas. There are three main properties of a radio wave that can be altered to do this. The first is amplitude, which is the height of the wave. The second is frequency, how many waves pass a point each second. The third is phase, which is the position of the wave at a specific moment. In tactical two-way radios, the most common types of modulation are amplitude modulation and frequency modulation. Amplitude modulation changes the strength of the carrier wave to match your voice or data. Frequency modulation adjusts the wave's frequency, making it more resistant to noise and interference. This makes FM very popular in tactical environments where signals can bounce around or get blocked. When you press the push-to-talk button on your radio, your microphone picks up your voice and converts it into an electrical signal. This signal then modulates the carrier wave, encoding your message onto it. The radio then transmits this modulated wave as a radio signal. On the receiving end, another radio demodulates the signal, reversing the process to recover your original voice or data. Modern tactical radios often use digital modulation, which turns your voice into a series of ones and zeros before transmission. This digital method allows for clearer audio, the sending of text or GPS data, and stronger encryption for secure communication. It also helps make better use of limited radio spectrum, letting more users share the same frequencies without interference. In tactical situations, the choice of modulation impacts not just how clear your voice sounds, but also how far your signal can reach, how long your battery lasts, and how secure your communication is. For example, FM's resistance to noise makes it reliable in urban or wooded areas where signals may bounce or be blocked. Digital modulation, although more complex, offers features like silent operation, text messaging, and the ability to extend range using repeaters. These features are especially useful for teams working over large areas or inside buildings. Understanding modulation helps you pick the right radio for your needs. Whether you want simple, reliable analog FM radios or advanced digital systems with encryption, the type of modulation used will determine how well your communication performs in the field. Always match your radio's modulation capabilities to your operational requirements. Clear, secure, and dependable communication can be the key to success in tactical operations.